Hi and welcome to the breadboard. In this video we're going to look at upgrading the memory on a number of different ESP8266 type devices. One of the reasons why you may want to do the upgrade is some of the smaller devices only come with about 512K of flash, or in the case of Sonoffs you come with a megabyte of flash. And if you want to be able to do any upgrades like over the air or have much more complicated programs, you can't fit it into the available space. So what you need to do is basically take away the old memory flash chip and replace it with a new one, and we're going to have a look at how you would do that. I'll be using my nice Weller soldering station to do the soldering and upgrades, making use of the fine tip pencil and also the hot air gun to make it a little easier to remove the chips off of the board. So these are a few samples of the ESP8266 devices that I have. This one here is an ESP01. It's got the ESP8266, the flash ROM, a little bit of a 10-pin header on the bottom. And what it has is basically just one GPIO pin. This one is basically an ESP12. It has a lot more GPIO pins. So this one, the memory chip is right here as a flash, and we're going to be taking that off and replacing it with the bigger one. The one that's on there is a 4 megabit, which is a 512 kbyte. The one on here is the same flash size, which is 512 megabytes. The ESP8266 here, as you can see, this one you can't get to the flash. Anyway, that's one that I probably wouldn't bother normally updating, but we'll see. This one is one of the early Sonoff boards. You can buy this just as the board, but preferably these days everybody gets it in a case like this. The flash memory on this one is actually on the bottom here, and if I can look closely enough with this one, see if I can tell what chip is on here. It is a Win bond, but I can't see what size it is. I'll have to grab a magnifying glass. Anyway, we'll have a look at that in a moment. And then the last one, of course, is the Sonoffs themselves. Now these are the more the original ones. These are 10 amp versions. I do have bigger ones, but the boards are basically the same, so we're going to look at upgrading one of these. I'm going to be doing some reviews of the bigger ones in the next couple of days, and when we do that we will also look at upgrading the memory and then reflashing them. So here's the inside. As you can see, is the ESP8266 is on the bottom and the flash memory is on the top, but it's really close to this LED. So what I'm going to do for all of these is I'm going to use the hot air gun from my Weller WXR3 soldering station to heat up the memory chip. I don't really care if I damage it, and then let it just drop off the board, or actually let the board drop off the memory chip. When we put the new one in, we're obviously going to put it back in the same place. The chip that I'm using for these are they come in strips of 25, or I got them in strips of 25 from eBay, and they're actually a slightly bigger footprint. But if you bend the legs in a little bit, and we'll show you this as we go along, use a pair of metal tweezers so you don't get any static and just tweak them in just a touch, they will actually go on the board without an issue. The nice thing is that you can get these ones with a bigger footprint really cheap. The ones with a smaller, let's say, correct footprint are more expensive. I think I paid something like $14 for 50 of these flash memory chips. So for me it's worth the little bending of a couple of pins just to make it fit properly. Let's rearrange things and start having a look at doing some upgrades. So what we're going to do is we're going to do the one Sonoff, we're going to do one of the ESP02s, and we're going to do the ESP01. And then we'll go to the bench and we'll reflash them with the latest Arduino Sketch software, and I'll show you how you can quickly hook up something like a DHT11 or DHT22 kind of temperature sensor just to show that it's all working. A suggestion before you take the chips out is to make a note of where pin 1 is of the flash memory, so that you know which way around to put it on when you are putting the new one back in again. In our case, for this particular board that we're looking at right now, pin 1 is this one here to the outside edge of the board. In your view, the bottom right hand corner right here, that's pin 1. So we know that once we put the new chip in, we're going to have to position it right there. Now let me just grab one of the chips so that I can show you the difference in size. So I've just placed one of the new chips right next to the existing one. There's the existing one, there's the new one. And as you can see, it is just a little bit wider. So we're going to have to bend these legs in to fit. Now again, pin 1 is marked by the little dot on the bottom right corner of this chip at the moment with the orientation I have. So anyway, let's get this first one off and then we'll look at bending and fitting the new one. So what I'm going to use is my Weller soldering station. This is the WX-HAP200. It's a 200 watt 24 volt hot air soldering gun. You can vary the airflow and of course the temperature. Look at my review on the WXR3 in a previous video. I'll link to it in the description. So I'm going to grab the chip with a pair of tweezers and then heat it up, lift the board slightly off the bench, and then I'm going to heat it up with the blower until the board literally drops away. Heating up both sides so that I don't just get one end loose and not the other. There we go, dropped off. So that's just all there is to it. So as you can see here, just doing a closer look, the chip is just marginally wider than it needs to be. So what I would suggest you do is take the chip and using a straight edge like a pair of tweezers or something, just tightly grip the legs where they're bent out a little bit and just push them in a touch, and that will be enough to hopefully make to shrink the pin pitch such that they will go onto the device nice and easily. So if you look at that now, and what I'm going to do is I'm just going to retouch the pins first so we have some nice fresh solder on here. Now what I'm going to do now is actually what I want to do is wet the bottom of these legs a little bit just so that they will tack on nicely. Place the chip back on the board, try and line it up. So lost the audio there for a bit. So what I'm trying to do here is I'm trying to align the chip nicely over the pins. Both sides are wetted with some fresh solder and flux. So all I have to do once it's lined up is tack on a corner and then work my way around the chip with the fine tip soldering iron. So as you can see here, I'm just tacking on the first pin to keep it in place. Bit difficult when you're under a magnifying glass, under a camera, etc., etc. Now I'm just adjusting the angle just so that the other pins are lining up on this side of it. Just tacking down the second pin and then resetting the first one to relieve some stress that there might be. That's all the one side done now. Sorry, I'm just losing out of camera shot there. Now I'm going around to the other side. Sorry again, out of camera shot, so I'll just skip this bit. So there it is, all done and dusted. Both sides are nice and cleanly soldered. There's no bridges apparently, so good to go. Another bit of annotation here because the audio had a faulty microphone, I think. So here we're going to use the ESP01. We're going to first of all remove the chip. I'm just pointing out where pin 1 is. Don't forget I mentioned that so you know where to put the new one on. Some boards do have it marked on the board, but there's no guarantees. So I'm just going to grab my tweezers, the hot air gun again, and we're going to heat up the board until the board drops off of the chip. The board being heavier, it should drop off once you've got it hot enough. If you try it the other way around and hope for the chip to fall off, it may not because the solder might be sticky enough that it'll still stay on the board. So we're just going to give it some heat. Shouldn't take too long here. The board's a bit smaller, so it should heat up a little bit better. Got to watch the chips around the memory chip though as well. Those little capacitors and things could heat up pretty quick and you could blow them off or dislodge them if you're not careful. So just be careful where you're aiming. There you go, the board just basically got blew away by the hot air gun there once it was done. So now we're there, and again what we're going to do is follow on and clean up the board with the soldering iron. We're just going to flow a bit of nice clean solder on it. And I think I pulled it out of view there, sorry. Oh, there we go. I remembered. So we're just going to touch it up with a bit of fresh solder. I use leaded solder, not unleaded. I think it gives me better joints than the unleaded. I never have really got into the unleaded, so I'm just touching up all of the joints. That way the new chip will go on there a lot easier. So there, we're done with that. Now we're just going to get the chip itself. So what I've done here is I've actually pushed this board into a breadboard just to give it some stability, because it is a bit smaller, so it'll be easier to solder and hold while I do this work. So I'm just adjusting the position of the chip on the board. So now we're going to tack on the first pin. Just going to make sure the rest of the chip is aligned. Carefully going to get into the other pin because you've got the crystal right there. This is where having a fine-tipped iron is handy. Just working down the other pins because I know it's aligned, and so I'm just tacking those on too. I may well go back again afterwards just to clean that up a bit once I'm not worrying about getting them onto the board. But yeah, that looks like a not much cleaner solder joint there. Just having a bit of care going around that crystal. So I'm just reversing the board now so I can get to the other side of the chip. Just popping it back into the breadboard. Now I'm pushing down on the top of the chip here just in case it's sprung up a little bit and there's a gap between the solder pads and the chip. So I'm just holding it down while I solder through those. As I said, they're all tinned already, so it's just a case of touching the soldering iron on to get them all to adhere and make the proper bond. So next up is the Sonoff board. So here we're looking at the memory chip. Note the pin 1 is in the bottom left hand corner. There's also a little white dot on the silk screen print to help identify where it's got to go there. Now what I'm looking at here is how best to remove the chip, and as you can see there's a lot of things underneath as well, so I don't want to keep the heat on too long in case it flows through and desolders anything on the bottom of the board. So what I'm deciding to do here is actually remove the 3-pin LED, it's red-green LED, so that I can have easy access to the chip to desolder it with the hot air gun. And then once I'm done, I'll put the LED back on. So I've just grabbed my Weller desoldering iron again. I'm just going to desolder the pins of the LED. Nice thing about using a tool like this is that there's no pressure on the board and it sucks nice and cleanly up into the soldering iron. The desoldering tool. If you're using a solder sucker like the spring-loaded ones, you do have a risk that the impact onto the board when you hit that plunger button, you could knock the pads off. But in this case, it's not happening because I've got a nice tool to do that. You could also use solder wick if you wanted to. And there's the LED cleanly out. Just pay attention to which orientation it goes in the board so you can get it back in the correct way when you're done. See, nice clean holes there. So the next step now is going to be to, again, hold the board with a pair of tweezers and heat up the chip with the hot air gun so that the board falls away from it. Okay, so applying the heat, again, making sure you don't get the heat on too much of the other components so you don't melt anything or desolder other components off the board. That would be rather disastrous. So we're just heating up both sides of the chip, trying to do it evenly, keeping it fairly close, lifting the whole board slightly off the table so that when it does desolder, it'll just drop the board back on the table and it will make a clean break. So a little more heat, should be any moment now. There we go, so that's done. Now in this case, I have the old chip is on the bottom here that I've just pulled off, and the new chip is just above it. This is a WinBond 8 megabit chip. This is the WinBond 32 meg, and as you'll see, in this case they're both the same size, so I do not have to bend the legs, which is kind of cool. So the Sonoffs, hopefully, and all the new ones are using this bigger chip, and I have a bigger pad for you to use it. So that's going to be excellent. I'm just going to be able to drop this right on there, a little bit of solder, and away we go. Sorry, I'm doing this under a magnifying glass and also under a camera lens and various other things, so it's not easy to see what's going on over time, at least for myself. So what I'm going to do, like before, I'm going to tack one corner in this case, and then I'm going to work my way around the chip. I'll line it up as best as possible to start, of course. And that's the first leg done. Just let that settle down if I push my finger on it, just so that I can push it a little bit better onto the board. Now we're going to go to the other opposite corner. That's got that one. Let's just now solder the rest. And there we have it. That's the Sonoff done. Now, any other ones you come across, as long as you can access the chip, then it's going to be relatively easy to do, like I've just shown you. And this is the chip that we replaced here. We replaced the 4 megabit with a 32 megabit. Now, in order to program this, we need to set certain pins to a high and low state. You need to take GPIO Zero low when you want to do serial programming. So what I've done is I've got one of these boards and I've just put some jumper headers on the back of it. So here's the close-up of the ESP, and so this shows it actually configured for programming right now, using the pin D0 to ground, IO15 to ground, the chip enable to plus 3.3 volts, and the plus 3 is supplied by the header right here. Okay, and if you remember looking at this, you can see here's a header 3.3, receive, transmit, ground. Now this is looking at the top of the board with the antenna at the bottom. Here we're looking upside down, so things are reversed, right? So 3.3 volt here, ground here. The green wire in this case is the receive, and the transmit is the, in my case, blue wire. Alright, anyway, let's go and get the software up and running. So the download of the Sonoff software, and this works with the ESP201, the ESP01, and a huge range of Sonoffs, is from GitHub, arndst/Sonoff Tasmoda. This is the latest version. As you can see, just only hours ago there were updates to this, and this is now the current one that you can use to download. It uses the Arduino IDE, and all the instructions are already included in the GitHub as far as how to download this software, configure it, and load it into the ESP8266s. This software will fit into a 1 megabyte chip, but it will not fit into a 512 megabyte chip. So that's why I upgraded some of these devices so that it will fit, and I can do over-the-air updates for it. And this software fully supports over-the-air. I will look at this in a separate video as far as what there is in this software and how you use it. But in this case, I'm just going to quickly go through, configure it, and get it up and running. And there's a few things. All of the libraries and everything else that you need to run this is all well documented in the wiki for this product. So once you've done that, load up the Arduino IDE, open the project that you've installed as per the instructions from GitHub, and you will end up with what you see here. So this is the main Sonoff page, and then you've got all of these configuration items. If you actually just hit the verify, it will compile the entire application and let you know whether you got all the libraries installed properly and everything else. And if you don't, you'll get the usual Arduino IDE error messages that will tell you that it can't find certain files and things like that. So you just have to make sure you get those loaded. It's in the complete list from the GitHub website, so just follow the instructions there and it will work once you're done. With this latest IDE, and I'm not sure if it's in the one right before it, but in this one, once you select the board, when you've got it loaded, you select generic ESP8266 module. There are some other ones you can pick as well, but the one we're interested in is an ESP8266. You select that, but what you can also do here is you can select the flash mode. Now the flash chips I've got, I selected DIO mode as opposed to quad IO. This is using single pins for talking to the flash versus doing it 4 pins at a time. For some reason, maybe the memory chips I got don't fully support quad, or for some other reason it wasn't working, but it wouldn't boot up properly. So I'm using the DIO mode for the flash. I haven't changed the frequency. You can actually run these at 80 megahertz. Let me just change that now anyway, what the heck. And you can pick that, the flash frequency, the CPU frequency, the flash size. Now the default would be 512, and I've gone up to the 4 meg because that's the chips that I put in. Now if you were using one of those ESP8266 mods that I lifted the metal lid of, only to discover it already had the 4 meg chips in, then you would stay with this. If you're using a Sonoff, then you would pick one of the 1 meg chips. Right, now I'm not sure what all these different ones are, but it's 1 meg chip, which was 1 megabyte. Yes, it's a 1 meg chip. These are the SPI sizing, these 192s. I'm not sure what all of them mean necessarily, but you either pick your 512 meg chip, which is the default ones for the ESP, a lot of the ESPs, the 1 meg, which is the default for the Sonoffs, or in my case, I've put in now the 4 meg chip. So what I'm picking is the 4 meg 1M SPIFFS. I'm not sure what the differences are, but I do know this one works, so that's the one I picked. And then once you've compiled it, you simply have to verify you've picked the COM port you're using, and in my case I'm on COM 4, and then hit upload. And once you've hit upload, it will compile again, and once it's finished compiling, it will start uploading. And there we go, it's starting to upload now. Note to self and note to young players too, if you've just set the jumpers to be into program mode, you have to cycle the power in order for it to go into programming mode. And then when you hit the upload, it will go in. So two things that I didn't quite deliberately there, but in focusing on doing the recording instead of programming, I had a putty session open which was holding the COM4 port, which this device is using for programming, and I also hadn't cycled the power since I set the jumper for programming. So those are two things you need to remember to do, and then you will get a screen like this where it's slowly updating all of the data to the ESP8266, and now it is done. So all you need to do is remove the pin 0. Let me just find that again. Alright, so this pin 0, which you ground, so this one here is for serial programming. You can leave pin 15 as it is, but you need to take 0 from low, just open it. You don't have to actually tie it to high, because you can actually use it as a general purpose input after the fact, and the Sonoffs have their button for turning the relay on and off and things actually on GPIO Zero. So as soon as you unplug it and you reboot by power cycling the device, it should come back to you and start working and giving you messages. So I'm going to bring up a putty session now connected to COM 4. So it's connecting to my Oaks Clan home network. Once it's connected, it's going to look for a MQTT server, but of course it's not being found. Now what I've got is it's got an IP address of 235. So what I need to do is basically browse to that IP address with Chrome or pretty much anything else I want to use, and I will be able to configure it. So let me just go to an empty screen, the web interface. So this is the interface you get from that software automatically. So it's come up by default as a Sonoff basic module, and it is. We can also configure the Wi-Fi, which I actually pre-programmed, but if you didn't and you connected it through pressing the one of the buttons or the input pins to make it go into AP programming mode, then you can set these yourself and change them. Information gives you basically everything we just talked about, but in a nice little neat list. And the console firmware upgrade is the where you can actually upgrade the module over the air, or by picking a file. So this one here, right now, this is the default URL, but you would normally set up your own web server that you would access a file called sonoff.ino.bin. And the reason why I wanted more memory is so that I could actually do that firmware upgrade over the network without actually having to have physical access to the device. And the last thing that's in this software is the console. Now I'm just very quickly skimming over this because I will do a separate video about this. So that pretty much shows the ESP201 upgraded. The process for the other boards, whether that be the ESP01, which is the little one with the 8-pin header, or the Sonoff, is pretty much the exact same deal. You just plug in your 3.3 volt TTL serial connection, provide it with some power, and then you just follow the same process. In the case of the Sonoffs, you would push the button that is already part of the Sonoff and then power it up, and then you would do your programming. Do not run the Sonoff on the mains while you plug in the TTL serial. You risk electrocuting yourself, damaging your PC, or other horrible things. Power the Sonoff, all the ESP8266, whatever you're doing, from a local 3.3 volt supply, either part of your TTL serial port or from some other source while you're doing your programming, and only reconnect to the mains or whatever you're using it with once you've done that and you've disconnected and put it back in its box. I don't want to be responsible for you killing yourself or hurting somebody or damaging some piece of kit. Anyway, that's really all there is to upgrading a ESP8266, whether it be one of these baseboards or a Sonoff, to use a bigger memory chip, and then uploading new software to use it. Now, like I said, in the Arduino software, you need to make sure you configure it to use the 4 meg chip under Tools, and once you pick the ESP8266, you just make sure you've got your flash size set to the 4 meg chip if that's the one you're using. Just follow the instructions on the GitHub site, and I'll put the actual link to this in the posting as well. And you can't really go wrong. I'll also provide a link to Pete Scargill's tech blog, where he has all the information and lots of other things about Sonoffs and ESP8266s, etc. Anyway, I hope you enjoyed the video. I hope you get a bit of confidence to upgrade your own devices to use more memory so that you can do over-the-air updates and things like that. I will do a separate video showing you the over-the-air update once I've configured a server to host it. And we'll also look more about the features of this software and also Pete Scargill's. But this video was really all about upgrading the memory, verifying that it will work, and that you can get your Sonoff or ESP8266 device back up and running quite happily.